So now we are going to solve one numerical problem using the not a direct method, using the alternate approach, means in which first we write a polynomial and then try to find out the unknown of a polynomial with the help of a second equation. So what is the problem? Problem is obtain a cubic spline function for the following data. What is the data? Data is at x equal to 0 the value of fx is a 1, at x equal 1 the value of fx is a 2, x equal to 2 the value of fx is a 33, and at x equal 3 the value of fx is a 244 under the natural spline condition, because without the natural spline condition we unable to find the unknowns, all the unknowns. Maybe there is some other means a condition, with the help of that condition we also able to find out the values of unknown, but in general under the natural spline condition. What is the natural spline condition? As earlier we discussed, at second derivative at x equal x0 and at x equal xn equal to 0. So for sake of a simplicity, if we write here, this is a x0, this is a x0, this one is a f0, and this is a x1, this is a f1, this is a x2, this is a f2, this is a x3, this is a f3, x3 and f3. So first of all we write a what? We write a formula of fx, and formula means a relation between m0, m1, m2, mi minus 1, mi plus 1, fi minus 1, fi plus 1, and what is the function for each class interval. So for sake of a simplicity, here already we write the formula, this one is a formula. So how we find the solution? Here we know that, as we write here, as here we derive already in previous lecture. So here we write we know that this one is a relation between different m, and this one is a function for x ranges from xi minus 1 to xi. For sake of a simplicity, first we write a what? First we write a polynomial for x0 to x1. So here we put I equal 1. Then what is the fx? Fx become 1 upon 6h inside x1 minus x whole cube mi minus 1 or m0. You may write m0 because I equal to 1, so m0 plus x minus x0 whole cube m1 plus second term 1 upon h. H is obviously h equal, we put the value of h later on, this one x1 minus x f0 plus x minus x0 f1. This is a second term. Similarly we write a third term minus h by 6, and here we put x minus, here x minus, not a, this one is a, I think this one is written not a correct one. Here we correct this one, this become what? xi minus x, so x1 minus x m0 plus x minus x0 m1. Okay, so we put these values here, from here, this one is a value of x0, this one is a value of f0, x1, f1, x2, f2. So we put these values here, so basically, so here we put the values of x1, x0 and h So what is the value for x1? x1 is a 1, x0 with a 0, f0 with a 1 and 2. Here if we put the values, so what is the values? Values become fx equal first term is a what? 1 upon 6h, and h is a what? H is a 1, because here what is the h? Difference between x1 to x0 is a what? 1. Between x2 to x1, 1. Between x3 to x2 with a 1. So here we put the value for h with the 1. So what is the fx? Fx with the 1 upon 6 inside x1 with a 1 minus x whole cube. Here x1 with a 1 minus x whole cube, m0. We write m0 plus x minus 0, x0 with a 0, m1 first term plus what? Plus 1 upon h, then obviously 1 h, here we write a 1 minus x whole cube, f0 with the what? Sorry, f0 with the 1 and f1 with the 2. So here we write a f0 with the 1 plus x minus 0, f1 with the 2. Here we write this term minus h by 6 means a 1 by 6. Here if we simplify this 1 minus x, not a cube here, basically this one is a 1 minus x, because here there is a x1 minus x only, x1 minus x only, so x1 is a 1, so 1 minus x. So 1 minus x, here we put what? Here we put m0 plus x minus 0, here we write m1. This is the fx, x lie between 0 to 1, or x is a x0 to x1. This is a cubic spline. So what is the remaining term? Remaining term is a what? There is a need to calculate the value for m0 and m1. m0 and m1. m0 and m1. So in order to find out the values of m0 and m1, m2 and m3, we need to put the values of for I equal to 1, I equal to 2 here. So if we write this formula here, then this formula become what? This formula become mi minus 1 plus 6 mi plus mi plus 1 equal to 6 upon h square fi minus 1 minus 2 fi plus 1 fi plus 1. So once we verify mi minus 1 plus 4 mi, here we write a 4 not a 6, this one is a 4 mi plus mi plus 1 equal to 6 upon h square fi minus 1 plus 2 fi, and here I ranges I equal to what? I equal to 1, 2, I equal to 1 and 2 for the internal nodes only, because I equal to 0 is a initial node and I equal to 3 with the what? Terminal node. So if we put I equal to 1, this become what? This become m0 plus 4 m1 plus m2 equal to 6 upon h square with the 1. This become f of 0 minus 2 f1 plus f2. So if we put the value for 6 into f0, f1, f2. So what is the value of f0? 1, 2, 33. So here we write 1, 2, 33, 1 minus 2 into 2 plus 33. So with the help of this one, we find the one equation. Another equation, if we put I equal to 2, then this become m1 plus 4 m2 plus m3 equal to 6 upon 1 f1 minus 2f2 plus f3, this becomes 6. f1 is 2, so 2 minus 2 into 33 plus 244, because the value of f3 is 244. So after simplification of this one, we get two equation, and after solving these equation we get what? m1 equal to this one. In order to save the time, already we write what? We write the values of m1 and m2. Means we solve these two equation, this equation and this equation. We solve these two equation with what? With condition of a natural spline. What is the condition of a natural spline? m0 equal to 0 and m3 equal to 0. So here we put m0 equal to 0 and m3 equal to 0. Then this one is a equation of two equation and two unknowns. So we solve these two equation, 4m1 plus m2 equal to 6 times this one is 1 minus 4 plus 33, this means 1 minus 4 minus 3, this means 30, this one is 180, means minus 4 plus 1, this become minus 3, 30, so 180, so 4m1 plus m2 equal to 180, means we simplify by putting m0 equal to 0, m3 equal to 0, because this one is a condition of a natural spline, this one is already given in the problem, this one is already given in the problem, m0 equal to 0, m3 equal to 0. So we get after solving the simultaneous equation with these two condition of a natural spline, this is the condition of a natural spline. This one is a true for all cubic spline, because natural spline second order derivative at initial and terminal point equal to 0. So once we find the values of m1 equal to minus 24 and m2 equal to 276, so we put these values of m1 and m2 here, m1 and m2 here, m0 and m1 here. Then we find what? We find fx equal, if we write fx equal what? fx equal 1 by 6, inside here we write 1 minus x, m0 with a 0 plus whole cube, x minus 0 whole cube, and m1 is a what? m1 is a minus 24, here we write a first term, second term plus 1 into 1 minus x into f0 with a 1 plus x minus 0 f1 with a 2 here plus, not a plus, minus 1 by 6 or 1 by h. So what is the formula? Once we verify this formula, this one is a h by 6. So this one is a h by 6 or 1 by h. Once we verify this one, this one is a h by 6. Obviously this one is h by 6. So here 1 by 6, inside 1 minus x, again m0 with a 0 plus x minus 0 into minus 24. So if we simplify this one, then this term becomes 0, this term becomes 0, this term also becomes 0, and if we simplify, this become fx equal 1 by 6 inside minus 24 x cube, and from here if we simplify, plus 1 minus x plus 2x, means 1 minus x plus 2x, 1 minus x plus 2x, and from here 1 by 6 here, and this one minus 24x, So after simplification, this become minus 4x cube, and this become minus x plus 2x, this become 1 minus x, 1 plus x, and this become 6 4s minus 4x, minus 4x. So this become, I think, minus 4x cube plus, sorry, not a plus, minus 3x plus 1. So once we verify this result, okay, 5x plus 1. So what will happen here? Sorry. So this one is a not a plus. So this one is a minus. So if minus, then this become plus. So this become plus 5x. 5x plus 1. So fx equal this one. Fx equal this one. So if we write in a new page, fx become what? Fx become minus 4x cube plus 5x plus 1. This one is valid for 0 to 1. This one is a cubic polynomial that we able to fit for the class interval 0 to 1. Similarly, we put I equal 2 in this formula. In this formula we put I equal 2, then we find xi2 means I equal to 2, then x1 to x2. We find x1 to x2 and putting the values of m0, m1, m2, then we get one another fx. So I am not going to find cubic polynomial means for I equal to 2. You may put the value of I equal to 2 in this expression, then after simplification you will get the result means a cubic polynomial between x1 1 to 2 and similarly 2 to 3. So here already we write a result. What is the result? This is basically this is a fx. So this one is a x lie between 0 to 1. In a similar manner, as we find the p1x, as we find the p1x, which is also known as here p1x. Here why we write this one is a p1x, because this one is the first polynomial lie between 0 to 1. So fx equal minus 4x cube plus 5x plus 1. I equal to 2. We find the fx between you may say p2x between what? Between x less than 2, and similarly fx equal p3x x lie between 2 to 3. Similar manner as we find from for 0 to 1. So this is the final result. Fx equal p1x, x lie between 0 to 1, here x lie between 1 to 2, and here x lie between 2 to 3. So this one is a cubic polynomial, required cubic polynomial, required cubic function. This one is the answer. This one is the answer. So what is the summary of this lecture? Means how we solve any numerical problem for a given problem. First of all, we write fx for a different class interval, then with the help of a second equation means first we write fx for different class interval, then we write a second equation mi minus 1 means a relation between mi and fi, and then we put I equal to 1 in a fx, then we find the fx for x0 to x1, and in a second equation which is a relation between mi minus 1, mi plus 1, fi minus 1 and fi plus 1, we find the values of m0, m1, m2, m3. Once we find the values of m1, m2, m3 up to mn, and how we find the m0, how we find these values? Using the condition of a natural spline. Once again I repeat this statement, without using the condition of a natural spline means m0 equal to 0 and mn equal to 0, we are unable to find out the values of unknown of a relation between mi and fi. So once we find the values of m1, m2, m3, mn with the help of m0 and mn, then we put these values in here m0, m1, for I equal to 0 and I equal to 1, M1, M2, I equal to 2, I equal to 2, M1 and M2, I equal to 3, M2 and M3. Once we put these values, then after simplification we get this result, So, this one is a summary of this lecture.